Hello dear friends, let's solve this paper, Winter 24, Component 2 on IGCSE Physics MCQ paper. A student uses a meter ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? Okay, so all of them are given in meter. First, let's rewrite them into millimeters. So it's 0.2932 meter, meaning it's 290, it's 29.3 centimeter or 293.2 millimeter. And second one is 0.293 meter, this one is 293 millimeter. Third one is 0.29 meter, which means 29 centimeter. This doesn't have millimeter detail, 290 millimeter. Fourth one is 0.3 meter, which is 30 centimeter again. It doesn't have millimeter detail, so it's 300 millimeter. Out of this, the first one is far beyond millimeter. So the second one is millimeter, 293 millimeter. Option B. Yeah. So you might think that 290 and 300 also end up in millimeter, but look at their last digit. They are not significant here. It's a 0. So it's, you can write it as 29 into 10 power 1 millimeter. The last one you can write it as 3 into 10 power 2 millimeter. So they are not significant figures. Yes. A rocket travels with an average speed of 6 km per second for 2 minutes. What's the distance traveled by the rocket? We know that speed is distance by time. Distance is speed into time. So we can multiply 6 km per second into 2 minutes, that we have to convert into seconds. So 2 into 60 seconds. So 720 km. Yeah, that's answer, 720 km. The diagram shows the vertical forces acting on a ball as it falls vertically through the air. The ball does not reach terminal velocity. Which road describes what happened to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air. Now, just the ball being released, now the velocity is 0 and this will start increasing because of the gravity. Now, the resultant force is two force we have to calculate. One, weight acting downwards, the second, upthrust acting upward. In both, weight is due to gravity, that's not going to change, but the upthrust, it will increase as the speed increases. In fact, upthrust is directly proportional to the velocity square. So as the ball falls, the speed will increase. As the speed increase, the upthrust will increase. As the upthrust will increase, the resultant force will decrease. Okay. Then, since the resultant force is decreasing, the acceleration also will decrease. So both resultant force and acceleration will decrease. If it has reached the terminal velocity, then acceleration is 0, resultant force also 0. If there is no air or air resistance is negligible, then acceleration is constant. So the resultant force is a constant force downward. Yeah, okay. A coconut falls from palm tree at X. It has just started falling. Y is the point just before it hits the ground. What is the acceleration of the coconut at X? Air resistance can be ignored. Okay. So there are 2 points, X and Y. X being near top and Y being near bottom. They are asking what is the acceleration of the coconut. Options are less than Y, same as Y, more than Y. Okay. So near the surface of the earth, acceleration is constant because compared to the diameter and radius of the earth, this coconut tree or palm tree height is negligible. So it's same. It's the same as at Y. Car is driven round a bend in the road at constant speed. Direction of the motion of the car. What is the direction of the resultant force on the car when it is going? If it's a circular motion, the direction of the force is always in towards or outward the center. Okay, so this will be always perpendicular to motion of the particle. If some object is going in the circle, let's say now car is going in this direction, the resultant force will be perpendicular towards the center. So perpendicular to the motion and towards inside the bend. So we have two options, C and D, both are perpendicular, but D is outside, so it's wrong. Only C, it's inside. Perpendicular to the motion and towards the inside of the bend. That's the right answer. The diagram shows a drawbridge that is attached to a wall by a hinge at one end and the cable at the other. The weight of the drawbridge and the tension in the cable are represented by the labeled arrows in the diagram. There is a third force at the hinge which is not shown. The drawbridge is in equilibrium. Which arrow shows the possible direction for the force at the hinge? Okay. So now we have two forces acting. One is weight acting downward. Another one is tension going in this direction. Sorry, in this direction. Okay. Now we have to find the resultant force. So we will move this both vectors without changing the direction. First we will move the weight, then we will move the tension. Now we have to draw from tail to head. So this is our resultant force. This will act in the hinge. So it looked like option B, but it's wrong. Why? Because the question is which arrow shows the possible direction for the force at the hinge provided these are in equilibrium. If this B is the resultant force, then the entire setup must be moving in the direction of the B like this. Okay, but it is in the equilibrium. So opposite to this the force must act. So that's the equilibrium. Option D. I hope it's clear. Which quantity gives momentum? Yeah, it's Ft equal to mv minus mu, so it's force into time. Change in momentum is force into time. It's correct. Energy is released by nuclear fission. Yes. This nuclear energy is not obtained from sun. Yes, it has environmental effect, so B is wrong. Nuclear power stations do not need turbines. No, they need turbines. Turbines are part of producing the electricity. Nuclear will give energy. How to convert that energy into electricity? That is turbine's job. Yes. So A is wrong, B is wrong, C is wrong, only D is right. The diagram shows an object of mass m being projected with a speed v from a point P to a point Q. The object does work W against air resistance as it travels from P to Q. What is the kinetic energy of the object when it reaches point Q? Okay, so let's assume the object goes from P to Q. Okay, so maybe P to Q. Now potential energy at P is 0. Potential energy at Q is mgh. And kinetic energy at P is with some initial velocity half mv square. But this is not going to be the kinetic energy at Q because some energy is given to potential energy. Also some energy is given to the work done against the air resistance. Now the initial kinetic energy half mv square, this is equal to the potential energy plus the final kinetic energy plus the work done against the air. Right? They are asking the final kinetic energy. So let's rewrite this equation. Initial kinetic energy minus potential energy minus W. Which option is that? D. Yeah. The diagram shows a Sankey diagram of electric. Okay. So input and scale distance between two lines is 40 joule. Okay. So energy input has how many lines? 15 lines. So 15 into 40 is 600 joule it has. Sound energy is one line, so it's 40 joule, 1 into 40. Thermal energy is 4 lines, so 4 into 40, 160 joule. Okay. Kinetic energy is 10 lines, so it's 400. What they are asking, what is the total wasted energy shown by the diagram? So wasted energy is sound energy and thermal energy. Now this is 40 plus 160 is 200 joule. B. Elephant of weight 40,000 Newton stands with all 4 feet on the floor. The average pressure on the floor due to the elephant foot is in contact with it is 34,000 Pascal. What is the area of each foot of the elephant? Each foot of the elephant. Okay. We know that pressure is force divided by area. We have to find the area. So area is force divided by pressure. Force is 45,000 Newton divided by pressure is 34,000. So Newton per meter square. So the answer is 1.32 meter square. So it's 1.32 meter square and you choose option D, then you are wrong because it's the area of 4 legs, 4 foot. What they are asking, what is the area of each foot of the elephant? So we have to divide it by 4. 1.32 meter square divided by 4, which is 0.33 meter square. Option B is the right answer. Some air is trapped inside a metal container with a tightly fitting lid. The container is heated strongly behind a safety screen. The lid is blown off by the increased pressure of the air inside the container. What causes the increase in the pressure? Increased pressure of the air inside the container. Okay, it's a tightly fitting lid, so the volume is not changing, but we are heating, so it want to expand the volume. It has to increase the volume. The temperature is increasing, so the particle will start move more quickly. That's the answer. That's why option B is the right answer. Let's look at other options. Each air particles expands and it takes up more room. No, the particle size does not change. The space between the particle will change. Number of particles inside the container increases. No, this again is mass. Mass will increase or decrease only if we add more particles or if we remove the particles. So C is also wrong. The volume occupied the air decreases. This is exactly opposite what happens. Volume of the air want to increase, not to decrease. So option B is the right answer. A very hot mug coffee is near a large unheated swimming pool holding 2 into 10 power 6 kg of water. Which statement is correct? We have the statements talking about internal energy of the cup or internal energy of the water. Now what happens is, a hot mug of coffee is a small mass of coffee, but it's higher temperature, so it will have some internal energy. And bigger swimming pool has large amount of water, but low temperature. It also will have some internal energy. Now the coffee pours into the water. Now what should happen is, there will be difference in temperature, right? Until that attained, then they will reach in thermal equilibrium. Then the coffee and the water both will be in same temperature. Okay, so whatever the energy given by the coffee is the energy received by the water, despite of difference in their masses. So what happens to the internal energy of the coffee? It will decrease. What happens to internal energy of the swimming pool water? It will increase. Not huge amount, but very slightly. So option D is the right answer. Yeah. A student measures the mass of water in an open container over 2 hours. The container is kept in a warm room. The results are on the table. Why does the mass of the water change? What happens to mass? As the time increases, mass decreases because of evaporation. The water evaporates. 1 kg block of aluminum requires more thermal energy to raise its temperature by 1 degree than a 1 kg block of copper requires. Meaning that the aluminum has a higher specific capacity than copper. E equal to mc delta theta. C is energy by m delta theta. Okay, if more specific heat capacity means that it takes more energy to increase the temperature by 1 degree. So aluminum has higher specific heat capacity than copper. Option C. A block of ice is at a temperature of minus 100 degrees Celsius. Energy is supplied at a constant rate. The graph shows how its temperature changes. At which point the ice completely changed state to water, and all the water completely changed into steam. Okay. So whenever the change of state happens, the temperature is constant. So we have two constant areas. Between 1 and 2, it is constant where all the ice is melting. So this is melting. And 3 and 4, where all the water molecule is evaporating or boiling. 3 and 4. So it's completely changed to water is end of 1 and 2, so it's 2. Completely changed to steam is end of 3 and 4, which is 4. So 2 and 4. Option D. Water waves are reflected at a plane surface. Which property of the wave is changed by the reflection? Frequency, speed, wavelength. It just reflects, so nothing will change. Only if it refracts, speed and wavelength will change. It is reflecting, so nothing will change. Only the direction of propagation is changing. So option A. A light ray is passed through air, glass, and water. At which point does the light speed decreases? So whenever the light enters from rarer medium to denser medium, or lower refractive index to higher refractive index, the speed will decreases. Okay, so wherever it enters from air to glass, there the speed will decrease. It enters from air to glass in two places. One is at W, where it enters from air to glass. Another one at Y, where it enters from air to glass. So it will be W and Y, option B. At which point the speed, light speed decreases. Yes. Okay. Plain water waves approach a narrow gap in the barrier, which diagram shows the diffraction pattern that would occur. Okay. So right away we can eliminate B and D because the wavelength do not change after diffraction. So B and C is not right. They are wrong. Look at the wavelength before and look at the wavelength after. After the wavelength is bigger. Now we have A and C. Now the wavelength is approximately equal to the gap. So it should spread more. In A it is spreading less. So A is also wrong. Only C is the right answer. When the wavelength of the wave is approximately equal to the gap, then it should spread more, not spread less. Yes. A ray of light enters a transparent plastic wedge from air and it's incident on the lower surface of the critical angle as shown. The angle of incidence I, the angle of reflection R, and the critical angle is C. In which ray diagram are the angles labeled? All the angles labeled correctly. Okay. Now first it is entering from air to transparent plastic wedge. Okay. Where it is entering from air to transparent wedge, this is incident angle I. Then the opposite angle R is refracted angle R. Now where the ray goes exactly at the surface boundary between the plastic wedge and the air, then meaning it is going in the critical angle. The incident angle in that case is critical angle. So the ray goes like this, there it is critical angle. So which image look like this? Option B. Yes. An object is placed 20 cm in front of a thin converging lens. The scale diagram shows how the lens forms a real inverted image. Which row gives the focal length of the lens and the distance of the image from the lens? Okay. Now the scale is 10 lines are 5 cm. So 2 lines is 1 cm. Yeah. Okay. First they are asking focal length of the lens. What is focal length? Where the rays goes parallel to the principal axis, meet the principal axis, where they cross the principal axis. So in this case, left before image, distance between the center of the lens to where they cross the line. So this is 8 line. So it is 4 cm. Now what is the distance of the image from the lenses? From the center, what is the distance? So this is, I think, 10 lines. So it's 5 cm. So 4 and 5 centimeters. Yeah. Radio waves are electromagnetic waves. What is the wavelength of radio wave of frequency 2 into 10 power 5 hertz? We know that V is f lambda and V is 3 into 10 power 8. This is true for all the electromagnetic waves. Now we just have to find the lambda. Lambda is V by f. So 3 into 10 power 8 divided by 2 into 10 power 5 meter hertz, which is second inverse. So second inverse cancel, we'll get 1 meter. So the answer is 1.5 into 10 power 3, which is 1500 meter, 1500 meter. D. A candle flame is placed in front of a loudspeaker. The loudspeaker produces a sound that causes air particles to vibrate. Vibrating air particles makes the candle flame vibrate in the same direction as the which shows the direction of vibration and candle flame and the nature of the sound waves. Okay, so it's a sound wave. So it's a longitudinal wave, and in they have already given that the particles oscillate in the direction of the propagation. So it's horizontal, left and right, and longitudinal. Option C. The diagram shows part of the magnetic field around the strong magnet. In which position does the magnetic pole experience the strongest force? Magnetic field is strong where the lines are close to each other. Out of all this, only in A they are close to each other, so it's A. There is a current of 0.60 ampere in a closed circuit. How much charge passes a point in the circuit in 2.5 minutes? We know that I is Q by T. We just have to find Q. Q is I into T. So it's 0.60 into 2.5 minute into seconds. So 2.5 into 60 seconds. So 90 ampere second, which is coulomb. 90 coulomb. Option C. Which two physical quantities have the unit joule per coulomb? Okay. Electromotive force and potential difference. We know by definition, electromotive force is energy by charge, joule by coulomb. Sorry, yeah, joule by coulomb. Coulomb is C. So it's EMF and PD. Option C. A copper wire is placed in an electrical circuit and its resistance is measured. The wire is then replaced with a second copper wire. It's twice the length and quarter of the diameter. What is the ratio of the resistance for the two wires? Okay. Now, we know the resistance is proportional to length and inversely proportional to area. Let's take proportional constant is rho, resistivity, that you will learn in AS level, but resistivity is a constant, proportional constant, rho. Okay, leave that one. Now R is rho L by A. Here it's given as diameter. So area is pi d square by 4. Area of a cylinder, area of a circle, if diameter is given, then it is pi d square by 4. It's actually pi r square. Instead of r, if you put d by 2, then it is pi d square by 4. Okay, it's d square by 4, 2 square. Yes. So instead of A, we are going to write L divided by pi d square by 4. And this 4 is in the denominator of the denominator. So we can write it as 4L by pi d square. Okay. So this is for R. Now let's write for R1 and R2. So rho 4L1 pi divided by pi d1 square. This is for R1 divided by rho 4L2 divided by pi d2 square. This is for R2. Now let's cancel this rho and rho, 4 and 4, pi and pi. What we'll have is L1 by d1 square and L2 divided by d2 square, R1 by R2. Now the d2 square will go to the numerator and d1 square will come to the denominator. So it will look like this. Okay. Okay, now we have come to the formula. Now L2 is given as 2L1. So instead of L2, we can write 2L1. And D2 is given as 1/4 of D1. Okay. Like L2, we cannot write D2. Reason is, our variable is area, not D2 directly. Area is D2 square. Okay, it's given as D2 square. So instead of D2 square, we have to write D1 the whole square. D1 by 4 the whole square. So which is D1 square by 16. So instead of D2 square, we are going to write D1 square by 16. Now let's put, instead of L2, 2L1, and instead of D2 square, D1 square by 16 in the formula. So L1 into D1 square by 16 divided by, instead of L2, 2L1 D1 square. Now we can cancel L1 and L1, D1 square and D1 square. So we will get R1 by R2 is, this 1 by 16 is in denominator, so it will go. So it's 1 divided by, there is already 2. 2 into 16, which is 1 divided by 32. So R1 by R2 is 1 divided by 32. So R1 is R2 is 1 is 32. Option D. I hope it's clear. Yes. Little tricky question, that's all. Which circuit contains a diode connected in series with the fixed resistor? Okay. What is the diode symbol? This is the diode symbol. Fixed resistor symbol is this. So which circuit has C? Yeah. In the circuit shown, resistor X has twice the resistance of resistor Y. Which statement about the circuit is correct? Current in the cell is greater than. Okay, let's come from last. The potential difference across X is greater than potential difference across Y. It's wrong because it's connected in parallel. So X and Y will have both same potential difference. So D is wrong. The potential difference across the cell is greater than potential difference across X. Just now we discussed it's wrong. It's the same X, Y, and the cell is same potential difference because they are in parallel. The current in X is greater than current in Y. Okay, X has the higher resistance. So X should have the lower current. So this is wrong. Y should have the higher current than in X. The current in the cell is greater than current in X. This is right because the current in the cell is current in the X plus current in the Y. So the current in the cell is greater than X. Also the current in cell is greater than Y. So A is the right answer. 4 ohm resistor and an 8 ohm resistor are connected in series with the power supply. A voltmeter connected across 8 ohm resistor reads 36 volt. What is the voltmeter reading when it is connected across the 4 ohm resistor? Okay. Now this is a circuit. Okay. Resistor across voltage across 8 ohm source 36 volt. What is the voltage across? 4. Okay. Now the resistors are in 2:1 ratio, 8 ohm and 4 ohm. Okay. So if 8 ohm has the voltage twice, then 4 ohm is half of 8 ohm, which should have half of the voltage. Okay. So 36 by 2, which is 18 volt. This is how we found even if the battery voltage is not given. If now, just for to think, what if something has 2 ohm? Then it will have 1/4 of the voltage, which is 9 volt. Super. If there is another resistor connected in series which has 16 ohm, then it will have 36 into 2, 72 volt across it. Okay, this is how many times the ratio, how many times the resistance is increasing, same amount voltage will increase. Just multiply. Yes. Okay. A metal rod XY is placed in a magnetic field so that it is perpendicular to the field as shown. Okay, magnetic field is in this direction, XY is in this direction, perpendicular. In which direction is the rod moved so that there is an induced current from Y to X? Okay. Okay. In which direction, if you move the rod, induced current is there, Y to X. So force is given, force is giving the current. Force is given and current is being asked. Okay. So it's generator rule. So we have to use right hand law. Okay. So we have to follow the right hand rule. Now, so field is in this direction. Okay. The current has to pass from Y to X. So it has to go up. So the thumb is looking at us, towards us. Okay. So out of the paper towards the observer. So it should be like this. Okay. Field is going from left to right. Current is going from Y to X. So the motion, we should move the wire in the direction of us. Okay. So field is in this plane. Current is in this plane. Wire must have moved in this plane. Yes. The diagram shows a basic electric motor. What are the names of the features? X is the coil, Y is brush, and Z is commutator rings. B. Two transformers P and Q each have 2000 turns on their primary coils and 1000 turns on their secondary coils. Both transformers are 100% efficient. The secondary of transformer P is connected to the primary of transformer Q. Q provides a motor with current 0.2 ampere. What is the current being supplied to the primary of transformer P? Okay. Okay, here is the whole setup. Okay, two transformers P and Q. Okay, this is P, which has 2000 in the primary, 1000 in the secondary, and this is Q, which is 2000 in primary, 1000 in secondary. Okay. The secondary transformer P is connected to the primary of the transformer Q. So this is right. Q provides motor with a current of 0.2 ampere. So the motor is there and the current 0.2 ampere is there. Okay. What is the current being supplied to the primary of transformer P? IP we have to find. Before that, first let's find the current supplied to secondary secondary transformer Q. Okay. So we'll find this one first. So in Q, what happens? We know NP by NS is IS by IP. Okay. Or NPIP is NSIS. You know this one. So we just want to find primary, okay, current in the primary of this one. So ISNS divided by NP. So it will be 0.1 ampere. So we just found the primary coil of Q gets the current of 0.1 ampere, the I prime. So this one is this 0.1 ampere. Okay, we found. Now to give 0.1 ampere, what current must be supplied to the primary of P? That's the question. So in P, again the same equation, we have to find the I primary. So it's the same equation, ISNS by NP, which is 0.1 ampere, which is given in the secondary, multiplied by 1000 turns in the secondary, divided by 2000 turns in the primary. So it is 0.05 ampere. Yes. So it's 0.05 ampere. D. So how you can logically solve is, it's 2000 turns in the primary of the first transformer and 1000 turns in the secondary. So the current should be doubled. Okay. Voltage should decrease to half and the current should be doubled. So if 0.05 is given, there it should be multiplied by 2. So 0.1 ampere current you will get. Then again 2000 turns given to the primary and 1000 turns into the secondary. So again current must be multiplied by 2. So 0.1 into 2, 0.2. Okay, that's how you should answer. Or you can do it in reverse also. 1000 turns have 0.2 ampere. Then 2000 turns must have half of this. So when you're moving one front, it should be half. So 0.2 ampere, half is 0.1 ampere. Again 1000 and 2000. So again it has to go off. So it's 0.05 ampere. Yes. Alpha particles are directed at a metal foil. Most of the particles pass through the foil with little change in direction. A small proportion of the particles are scattered back through large angles. What does this evidence suggest about the structure of an atom? Okay, so it's a small portion, small proportion. So meaning that most of the atom's space is empty. Okay, all of it consists a charged center. Why alpha particle is positive? The charged center also must be positive to scatter back through large angle. Okay, so it's option C. Why all the other are wrong? It consists of a charged center much smaller than size of the atom and with a little of the mass of the atom. So if little of the mass of the atom will affected. Only if there is more mass enough to rebound the alpha particle. Okay, consists of negative charge. If it's negative charge, alpha particle would have stick to it. So B is also wrong. It consists of a positive charge of the size of the atom containing small negative charges scattered through it. D, it's also wrong. So only C is right. Which statement correctly compares the properties of alpha particles and beta particles? Alpha particles are less penetrating than beta particles because alpha particles are more ionizing, B. And alpha particles have higher kinetic energy. Which statement about alpha decay is correct? So in alpha decay, 2 protons and 2 neutrons will be ejected. Okay, so it will become a different element. Let's see the options. Option A, nucleus loses electrons. No, there is no electron nucleus. So option A is wrong. Option A is right. The nucleus changes to the of a different element. Yes. What is option C? The nucleus does not decay until after 1.5 half-life. No. Uh, This depends on number of nucleus, not one nucleus. Okay, C is wrong. After 2 half-lives, alpha decay will always stops. No, this is also wrong. This will go forever until all the undecayed nucleus become they have emitted alpha particles. So only B is right. Nucleus changes to that of a different element. An explosion in a nuclear reactor spread the isotope of cesium 137 across a large area. After 90 years have passed, the quantity of cesium 137 present in 12.5% of its original value. Sorry, present is 1.12.5% of its original level. What is the half life of cesium 137? After 90 years, it's 12.5%. This is what they are telling, right? So 100% of cesium become 12% of cesium. How it will become 12%? 100% must come to 50% in one half life. 50% must come to 25% in another half life, second half life. 25% must come to 12% in third half life. So three half life. So they're telling it's 90 years have done. So three half life is 90 years. So one half life is 90 years divided by 3, which is 30 years. So option C. Yes. Which type of object rotates around the sun with an elliptical orbit? A planet. Okay. Some might think moon, but moon orbits a planet. Moon does not directly orbit the sun. And it will go like this. Okay, watch some YouTube videos. Which statement about the sun is correct? Sun is powered by fusion reactions and electromagnetic radiation is produced. Super. To determine the value of Hubble constant, an astronomer measures the distance of a galaxy from Earth as 2.5 into 10 power 21 kilometer. She also measured the speed of the recession of the galaxy from the Earth as 5.2 into 10 power 3 kilometer per second. From this data, what is the value of the Hubble constant? Hubble constant is V divided by D. So 5.2 into 10 power 3 kilometer per second divided by 2.5 into 10 power 21 kilometer. So it's 2.08 second inverse into 10 power 18 minus 18. Yes. Yeah. Bye.